Elliott Sober. We are very glad to have Professor Sober with us today. Professor Sober, he is a professor in the Department of Philosophy at the University of Wisconsin-Madison. He has been working mainly in philosophy of biology and general philosophy of science. He has many books on these topics, and he has also many articles published in these topics. His last book, The Design Argument, is related to the talk he's giving today. It was published in 2018 by Cambridge University Press. Professor Sober, we are very glad to have you here with us today, and you're very welcome to share with us all your reflections and your thoughts. Thank you very much for accepting this invitation.
Thank you, Santiago. It's a pleasure to join with you and the group of fellow philosophers of biology in Colombia. And I look forward to our discussion. So let me begin. So you see already that there are two kinds of naturalism up here. And I'll be talking mostly about methodological naturalism. But more broadly, I'll be talking about both of them in connection with evolutionary theory. So let's have the next slide. Okay, so there's how I will be understanding methodological naturalism for this talk. It says straightforwardly, scientific theory should not postulate the existence of a supernatural God. Naturalism means in nature, supernaturalism means outside of nature. So you see why the terminology is chosen for that particular position. And this is different from what is called generally in philosophy metaphysical naturalism, which is a claim about what exists. So no supernatural God exists. Could I have the next slide, please? So methodological naturalism does not entail metaphysical naturalism. That's what the left-hand slide, the left-hand arrow with a slash through it means. The fact that scientific theory shouldn't postulate the existence of God doesn't show that there's no God. I hope that's obvious. But there is an arrow in the opposite direction, which is that if there is no God, then scientific theories should not say they are, at least if those theories are supposed to be true. So you see there's a kind of asymmetry between these two forms of naturalism. Just a comment looking forward to what's going to come soon in the talk. Notice how the two naturalisms are all about God, but I'm going to be broadening that by considering some other issues besides the existence of God in connection with the two naturalisms. You'll see this soon. Okay, let's have the next slide. Okay. So methodological naturalism tells scientists not to say that God exists, but I think it's usually understood as saying that they also should not think that the non-existence of God, they shouldn't claim that God does not exist in their scientific theories. The idea is basically that the existence of God or the non-existence of God, they're both off limits as far as what goes into a proper scientific theory. What does supernatural mean? What I'm going to be using the term to mean now, there's a bit of variation in the way the term is used sometimes, but what I mean is just literally outside of nature. And by nature, I mean the totality of events that happens in space and time. And as I mentioned a second ago, the two naturalisms, as I stated them, are both about God, but there's a more general category of the supernatural, which will be important soon in the rest of my talk. And a small point, that although methodological naturalism, as I've defined it, says don't say that God exists in your theory, it doesn't rule out the possibility that you want to put in your theory some claim about what properties God has if there were such a being. So that's left open, although I think most scientists who think that methodological naturalism is a good idea, they don't want to talk about God at all. They don't want to say that he exists. They don't want to talk about what properties he would have if he did exist. It's just off limits completely. Okay, let's go to the next slide. And here are the two main topics that I'll be talking about. Actually, there's something else that's left off of this slide, but the first one is there are different pictures about what God would be like if there were such a being, which I want to distinguish. And I want to talk about which of them are compatible with evolutionary theory as we understand it. And then later in the talk, I'll be getting at the idea of why should we buy this methodological principle that says you should not put the existence of God in your science. In between these two, I'll be talking about a topic that has been important in the history of this problem with respect to evolutionary theory, which is the question of whether mutations are guided or unguided. Many of you will know that Darwin, in his work, did not want to, he denied the existence of guided mutations. And one of his main correspondents was the botanist Asa Gray in the United States, who urged Darwin to put the existence of God as a guiding force for mutation into his theory. Darwin said he did not want to do that. So in between 1 and 2, as you see them on this slide, I'll be talking about the question of guided mutations and what kind of an idea that is, how to understand what it says. Okay. Okay, so here are the 3 views of how God is related to nature. If there were a being, we could put it hypothetically, if there were such a thing as God, how might that being be related to the evolutionary process and what we observe in nature? And I call these propositions C, D, and I for a reason I'll reveal to you in the next slide. But for now, just let's look at them and see how they're different. So the first one says that God causes the evolutionary processes to occur in nature, but those processes are not able to explain what we observe. And here, the specific thing that the proponents of this view of God have is super complicated adaptations cannot be explained by the theory of natural selection. You may be familiar with the idea of intelligent design theory. People who go in for that, you are going to say that evolutionary theory can explain some things in nature, but it cannot explain complex adaptations. Well, how do you explain the fact that there are complex adaptations? And that's where they say we have to bring in God, an intelligent designer who created in nature things that the evolutionary process on its own would not be able to do. So that's the C version of God's relationship to nature, to evolution, and to what we observe in nature. The D version, which I think is Darwin's view, but that's not why I'm calling it D, I'll get to that, is this is what Darwin thinks. He thinks, look, at least up to the time when he wrote The Origin of Species, I think he believed in God. He thought that God created the universe. But after that, God didn't have any involvement in making specific things happen in nature. So the evolutionary theory that he proposed, he thought was sufficient to explain what we observe without denying that there's a God who created the universe and allowed evolution in the first place to get going. So that's the D version. And you can see how there's no second arrow from God to the observations in D. In C, there is this second arrow that gets you there. And then finally, in the final version, God affects what we observe in 2 ways. First, he creates the evolutionary process, which influences what we observe. But separately, God also goes through that sort of bent arrow and intervenes in nature. That's why it's called I tip my hand here. I means intervention. God intervenes in nature. He doesn't let the evolutionary process go on its own once it's started. Okay, let's have the next slide. So here's what the 3 letters mean. C is what creationists believe now. They don't deny that evolution occurs. They just think that it can't explain what we observe, everything we observe, and that's why God has to be brought into the story. Was in the 18th century sometimes called deism. It's the idea that once God creates the universe and creates the laws of nature, the universe is a machine that just moves forward under its own dynamic, and God doesn't have to intervene in those natural processes at all. And as I said, that's, I think, more or less what Darwin believed up until the time he published The Origin of Species. Afterwards, he gradually became an agnostic, and he no longer believed in God. But I think before that, he did. He certainly wrote the language used in The Origin of Species, I think, shows you that he does think that God exists. He just doesn't think that creationism is true, the first version. And the third one, as I mentioned, is called interventionism. The evolutionary process affects what we observe, but there's another pathway that does so, namely God reaches into nature and intervenes in the evolutionary process and makes things happen there that perhaps could not happen without God's intervention. Okay, so now let me give you my argument for why I think that evolutionary theory, as it ought to be understood, does not rule out the idea that God intervenes in nature. And this is a little unusual. I think a more common view among philosophers of biology is that deism is obviously compatible with evolutionary theory. God starts the universe, and then God is hands-off. He doesn't intervene in anything that happens subsequently after the universe starts to exist. Obviously, that's compatible with what's going to happen inside of nature being governed strictly by natural laws. So I'm not talking about the deistic version of theism. I'm talking about the interventionist version here. And I want to give you an argument that says that evolutionary theory, as we have it today, does not rule out divine intervention. And I want to make it clear from the very beginning that I am not advocating the existence of God. I am not saying that God intervenes in nature. I personally am not into that at all. But I'm saying the theory as we have it does not rule that out. That's the claim. Okay, let's go ahead. Here's the argument. Evolutionary theory is a probabilistic theory. And it doesn't say of itself that it's causally complete. And that means that it doesn't rule out hidden variables. And finally, that means that the theory does not rule out supernatural hidden variables. And what I need to do before we move ahead is just point out some concepts that you see in this slide. You have the idea of causal completeness. You have the idea that the theory is probabilistic. And you have the idea of the hidden variable. So I'm going to try, I hope what I'll say in the next few slides will clarify what I mean by each of these concepts. Okay, so let's start with something easier to think about, namely coin tossing. So here are two probability statements about tossing a coin. The first one says that the probability that the coin will land heads, given that the coin is tossed, is 1/2. It's a fair coin, in other words. It's not biased towards head or biased towards tail. It's fair. And the second statement says the probability that the coin lands heads, given a complete description of how the coin is tossed, is either 0 or 1. And I think these two statements could both be true. I think there's no conflict between the two, which is an important point, as you'll see soon. If they're both true, then I want to say that statement number 1 is causally incomplete. That is, there's more influencing whether the coin lands heads than simply the fact that you tossed it. There's the exact way that you tossed it. There's the flow of air in the room. There's the surface on which the coin lands. All of these things are relevant. influences on whether the coin is going to land heads. So the first statement, though true, is causally incomplete if the second one is also true. And another way, a fancy way to say this that is used in physics, it's equivalent, is to say that although one is true, there are hidden variables. That is, there are causal influences on the coin's behavior that are not described in proposition one. Okay. So let me illustrate that now by going to the next slide, by talking about a simple Newtonian model of coin tossing that was invented by Percy Diaconis and his colleagues. He's a statistician and a probabilist. So it's a very simplified model, which makes it kind of easy to get a feeling for, though it's kind of pretty, as you'll see, I hope. So here are the simplifying assumptions we're going to make. The coin begins heads up in your hand, or on your thumb, maybe. The coin is going to land in sand, so it's not going to bounce around when it hits the floor. That's a simplification. There's no air resistance, so we can ignore that. And given those assumptions, it turns out that in this Newtonian model, there are basically two factors, two parameters that influence whether the coin will land heads or tail. The upward velocity, when you toss the coin, how fast is it moving when it leaves your hand and goes up? And the second is how fast it's going to be spinning. That's the angular velocity. So let's have the next slide. And you see these black and white regions. Well, the black regions are the regions in which the coin will definitely land heads. The white regions are the regions of parameter space in which the coin will definitely land tails. And you can see here that when the angular velocity and the upward velocity are very close to zero, the coin is going to land heads. It stayed heads, and you did so little to go like that it's just going to settle back where it was initially. But as you put more upward velocity and or more angular velocity, you'll move to a region in which it'll come up tails, and then a little bit more and it'll go to heads and so on. So you get this mixture for different values of velocity, of angular velocity and upward velocity, you'll get heads or tails, as the case may be. If you just look at this little diagram in the big way, you can see that about half the area of the square is occupied by black and half is occupied by white, which basically captures the basic idea for how this could be a picture of a fair coin. On average, it's going to land heads as often as it does tails, but each toss is not 0.5 for heads or 0.5 for tails. It's either 1 for heads or 0 for heads. It's a deterministic process given the exact values of these two physical parameters. But so to speak, if you don't know exactly how you toss the coin, then a good model is it's a fair coin because you don't know where in this parameter space the toss you just did is located. Okay, let's go ahead. And as I sort of said a minute ago, one is true because it turns out that people, when they toss coins, let's go back to the slide before, please, Santiago. When people toss coins, they don't control what they're doing with absolute precision. There's variation in how they toss the coin, and they tend to do what this picture says. Sometimes they'll toss in a black region, sometimes they'll toss in a white region with about equal frequency, which is why when you toss fair coins, they tend to land heads about 50% of the time, especially as you toss more and more. Okay, let's go forward to the next slide. And the reason the second proposition, so that's why the first proposition is true in this model, because when people toss coins, sometimes they use one pair of values for the two parameters. Other times, perhaps without themselves realizing it, they're using another pair. And so on average, they're occupying the black regions as often as the white regions, which is why you're getting 50-50 heads when people toss coins that are fair. That's why proposition 1 is true, according to this Newtonian model. The reason proposition 2 is true is we've adopted a deterministic model in which the point values of the two parameters determine either that it's definitely going to land heads or that it's definitely going to land tails. So that's why there's a 1 or a 0 in proposition 2. And I hope you see that these two propositions are not in conflict with each other. They're both true. The first one takes account of a very small piece of information, just that you toss the coin. The second takes account of a much more detailed piece of information, namely exactly how you toss that coin. And when you conditionalize on different propositions, you can get different probabilities for the probability, different values for the probability that the coin will land heads. Okay. Okay, so that's your, I want you to use that picture to think about how a deterministic and a probabilistic model are related to each other. Now let's talk about the idea of guided mutations and how they, whether they could exist according to evolutionary theory. And as you, I'm sure, are aware, the idea that mutation is unguided that's the received wisdom in evolutionary biology. Darwin thought it was true. Biologists now think it's true. But what does that mean to say that they're unguided or that they're undirected or random? It does not mean that they have no causes. What biologists typically mean by saying that mutation is unguided or random is on the next slide. It means, typically when scientists say this, that mutations do not occur because they would be useful to the organism. Mutations have their causes. Radioactivity causes mutations. Other things do too, like sunlight causes mutation. But that's not being denied when people say that mutations are unguided. It's this red statement that's the thought here. So let's look at what Darwin says on the next slide about this question. And it's kind of wonderful, I would say, that Darwin had this idea about unguided mutations without knowing anything about Mendelian genetics or anything really about any sort of modern idea about the mechanism of heredity. But this was his idea. It's a good question why he had this idea. It wasn't like he did the kinds of experiments I'm going to describe. But let's consider what he says here. It's based, Darwin's idea here is a beautiful metaphor that communicates the idea that yes, mutations have their causes, but they don't happen because they would be good for the organism. Okay, so this is from, it's not from The Origin of Species. I think it's from his book, The Variation of Animals and Plants Under Domestication. So Darwin says, this is the analogy that he starts with. Let an architect be compelled to build an edifice with uncut stones fallen from a precipice. The shape of each fragment may be called accidental, yet the shape of each has been determined by the force of gravity, the nature of the rock, and the slope of the precipice. Events and circumstances, all of which depend on natural laws. But there is no relation between these laws and the purpose for which each fragment is used by the builder. That's the analogy. How does this apply to mutation? Darwin says, in the same manner, the variations of each creature are determined by fixed and immutable laws, but these bear no relation to the living structure which is slowly built up through the power of natural selection, whether this be natural or artificial selection. So the rocks that fall from a cliff, there's a causal explanation why they have the shape they do. However, they don't have the shape they do because that would be useful to the architect who's going to build a house out of those rocks. So the analogy is mutations have their causes, but they don't happen because they would be good for the organism. I hope that's vivid as an analogy. That's Darwin's idea. Let's go ahead. Okay, so why is the denial that mutations are guided a kind of centerpiece of modern evolutionary biology, and has been more or less since Darwin? Is it an article of faith that's just, you have to believe it because I told you to believe it? Or is there some data, some observational data that actually supports that idea? I want to describe a very simple thought experiment that I think typifies what more complicated experiments would look like if you did them, which is the kind of evidence we have for thinking that mutations are unguided. So this is made up, and it's got lots of simplifications, but I hope you'll get a feeling for the kind of experiment I'm describing, although the example is very simple. Okay, so we're going to do an experiment on blue organisms. And in the experiment, we're going to place some of those organisms in a green environment and others into a red environment. Let's go ahead. And then we're going to see how often the organisms mutate to green and how often they mutate to red. So we're going to be monitoring mutation frequencies. They all start out blue. How often do they mutate to one color? How often do they mutate to the other color when they're in a green environment? And the same pair of questions for when they're in a red environment. So let's go ahead. So what we're doing is running an experiment that looks like that. The organisms are all blue to start with, and then they're either going to mutate to red or mutate to green, or of course not mutate at all. And the organisms will either be in red environments or green environments, and we'll get 4 frequencies, which describe how often, for example, the blue organisms mutate to a red environment when they're in the green, mutate to red, their own color becomes red. When they're in a green environment, how often they mutate to red when they're in a red environment, and so on for mutating to green. So you see there are 4 frequencies here. They don't add up to 1 because most of the organisms are probably not going to mutate at all. We're going to do this, we're imagining a very large experiment, so there'll be a few mutations that we'll see here. We want to see how often each of these 4 possible mutations occurs. Okay, let's go ahead. Let me add one more detail to the experiment. We're going to run the experiment so that protective coloration is advantageous. And when you don't have protective coloration, you're at a disadvantage. So that means that in a green environment, green organisms have higher fitness than red organisms. And in a red environment, the reverse is true. Namely, red organisms have a higher fitness than green organisms do. Okay, so that's the extra deal we have. We're doing some selection here. Maybe we're going to kill the organisms that don't match their environment and allow the organisms that do match their environment to survive and reproduce. We're running an artificial selection experiment. What will happen in that experiment? Let's go to the next slide. Let's suppose that the frequencies are pretty much the same as each other. Well, what does that mean? I think that shows that the fact that it would be advantageous to mutate to red in a red environment, and the fact that it would be advantageous to mutate to green in a green environment, and the fact that it would be disadvantageous to mutate to red when you're in a green environment, and it would be disadvantageous to mutate to green when you're in a red environment, basically that makes no difference to how often mutations occur. Mutations are not affected by what's good for the organism. Your data is telling you this, if these frequencies are pretty much the same as each other. Let's go ahead. This is what you'd expect to see if mutations were guided. If you're in a red environment, you should see more red mutations than green mutations. And if you're in a green environment, you should see more green mutations than red mutations. Likewise, mutations to red should occur more often when you're in a red environment than when you're in a green environment. And similarly, if you're in a green environment, you should see more mutations to green than to red. So the idea of guided mutation predicts inequalities in these frequencies, both horizontal and vertical inequalities in the 2x2 table. And that's exactly what you do not see in the experiment that I'm imagining. And it's experiments of this type that lead biologists to say with very good reason that mutations are unguided. They have their causes, but what would be advantageous to the organism is not one of those causes, just like Darwin said. Let's go ahead. So that's the conclusion I just stated, that from the data you have in the experiment, the reasonable conclusion is that the probability of these mutations are not affected by the fact that some of them would be better for the organism than others. And here's the next step. That conclusion is based on sample frequencies that you had, but maybe there are hidden variables. Maybe there are causal influences on mutation aside from the color of the environment. Maybe so. I'm not claiming that there are such influences, but maybe there are. For example, maybe temperature. Maybe this phase of the moon is an influence. We would like to control for all of these possibilities, but the point so far is the fact that we have no evidence for guided mutation in the simple experiment I described does not rule out the possibility that there are influences on mutation frequencies other than the ones we were considering in the experiment, namely the color of the environment. Let's go ahead. So this conclusion, based on sample frequencies, since it doesn't rule out hidden variables, it also does not rule out supernatural hidden variables. It doesn't rule out the possibility that maybe a couple times in the history of the Earth, God reached into nature and caused this or that mutation to occur. Little events like that don't show up as making any in our sample frequencies. We won't see this. And again, let me emphasize, I'm not saying that God does reach into nature. I'm not saying that God even exists. I'm saying that our data that we're basing our judgment about mutation not being guided, our data does not tell us that there has never been a hidden variable affecting the mutation process. We don't have any evidence that there was intervention. We don't have any evidence that there is this hidden variable, but that doesn't show that there never was such a thing. Or so that's my argument. Let's go ahead. So I hope you're getting a feeling for how the mutation story I just told you was like the simple example of coin tossing. Coins don't land heads or tails because this would be good for gamblers, unfortunately. And mutations don't occur because they would be good for organisms. And both these claims are compatible with their existing hidden variables. And what's more, the evidence for both of the claims that are bullet points here come from looking at the sample frequencies, how often coins land heads and tails in casinos, let's say. When you bet on the coins landing heads, does that mean that the coin has a higher probability of landing heads? I don't think so. And when it would be good for an organism to mutate to green, does that cause it to have a higher probability of mutating to green? Apparently not. Okay, let's go ahead. So what I've just said, and I'm going to ignore the creationist story at the top here, is that the little experiment we ran to test whether mutations are guided, that is, whether mutations occur in part because they would be advantageous, is compatible with both the deist model D and the interventionist model I. I don't think evolutionary theory tells you which of these is true. So yeah, that's my argument for saying that evolutionary theory is compatible with God's intervening in nature. Okay. And it begins with the idea that evolutionary theory is a probabilistic theory. It tells you what will probably happen. Okay, so that's the first topic that I wanted to talk about. And my example that I used to talk about, the first question was, are mutations unguided? And the answer is, as far as we know, yes, they are unguided. But the evidence we have for that does not rule out the possibility that sometimes guided mutations sent to us by God have occurred. Of course, we have no evidence that they've occurred, I think. Okay, now to the next topic. Why should scientists buy this proposition called methodological naturalism? Okay, so there are three arguments for methodological naturalism I want to talk about. First is you settle this by a matter of definition. You say, look, what does natural science mean? It means that you shouldn't talk about the supernatural things. That's what the words mean. And that settles the question. That methodological naturalism is true for the same reason that bachelors are unmarried is true. It's true by definition. Second argument is different from that. It says, look, the reason that science should not bring in supernatural beings into its theories is that statements about a supernatural God are untestable. And we want scientific propositions to be testable. That's why the methodological advice offered by methodological naturalism is correct. And finally, we have an argument, the third one, we want to consider, which says, look, there are bad consequences for science if you let God into science. Namely, science will effectively grind to a halt. It's a science stopper. That's an expression that is used a lot now to describe the disastrous effects that would occur in science if you allowed God to be introduced into scientific theories. And I want to consider each of these arguments, and then at the end, I'm going to add a fourth argument to the possible arguments for defending methodological naturalism. Okay, let's consider the first argument. By definition, this argument says the reason science should not bring in supernatural beings is that by definition, natural science says nothing about the supernatural. And my reply to that is sort of summarized by the difference between science and schmience. Let's suppose it's true that science, by definition, says nothing about supernatural beings. I think what someone would say who wants to bring God into evolutionary biology is, okay, what I'm proposing is not that it's a science anymore, but I'm going to call it a schmience. And by a schmience, I just means it's just like evolutionary biology, so I'm going to add this little element to it. And the point that I'm trying to make by this little joke about science and schmience is that the definition doesn't settle why we should do science rather than schmience. It doesn't, you've not made that argument just saying that science by definition excludes the supernatural. So that's what I think is wrong with this first argument. Let's go to the next argument. Oh, before we go to the next argument, this is another detail of the first, and this is maybe a little surprise. I want to argue that evolutionary theory actually entails the existence of some supernatural entities. Now I'm going to get really weird. Okay, let's go ahead to the next slide. And the supernatural entities I have in mind here are not God, they're numbers, mathematical entities. So here's the argument I want to give you for why evolutionary theory is committed to the existence of supernatural beings. I'm not talking about God here. So the premise, here's the argument. According to Platonism, the philosophy called Platonism, numbers are entities that exist outside of space and time. And the second premise of the argument says that mathematical evolutionary theory entails that numbers exist. And so it follows that if Platonism is the right philosophy of mathematics, then evolutionary theory violates methodological naturalism. It violates methodological naturalism not because it says that God exists. Of course, it doesn't say that. It violates methodological naturalism by saying that numbers exist if numbers are objects that exist outside of space and time. So you might now wonder, why should I think that numbers exist outside of space and time? Let me give you the argument. So let's go to the next slide. Here's a statement from number theory. There's no largest prime number. In fact, therefore, there's an infinite number of prime numbers. And I want to point out some properties that this proposition has. First of all, it's true. It's provably true from obvious assumptions about numbers. And here's some philosophy. I think this statement would be true even if there were no intelligent beings or physical objects at all. It's not about us. It's not about rocks or matter. Those aren't essential to what the statement says. So I think that what this statement says, what makes it true, is nothing to do with us or the material world. It would be true even if there was no matter in the universe. And I hope that gives you a feeling for why philosophers are often attracted to mathematical Platonism. The statement says that something exists, and it would be true even if there was no matter in the universe. So apparently it depends for its existence on things that are not in nature. They're outside of space and time, namely numbers. So this is certainly, mathematical Platonism is certainly a debatable philosophical idea, and I'm not claiming to have given a kind of full defense of it here. I'm just trying to give you a feeling for why it's not crazy. It's kind of got some plausibility to it. And I want to appeal to, so that's why I feel entitled to use that to explore the idea of whether evolutionary theory abides by the principles of methodological naturalism. I claim it does not because it says that numbers exist. And then I claim if Platonism is correct, evolutionary theory has just violated methodological naturalism. Okay, let's go ahead. Well, what about evolutionary theory? Where do we ever talk about numbers there? Well, here's a statement, simple statement that you might make if you're doing phylogenetic inference. For example, you say, maybe you're saying of these two lineages, the rates of evolution of some group of traits are not equal. What does that mean, that quoted statement there in the blue box? Let's go to the next slide. It means there exists a number d different from 0 such that the rate of evolution in the first lineage minus the rate of evolution in the second lineage is equal to d. And notice that statement says that numbers exist, or a number exists. So you maybe now see why I think that just doing routine science, there's nothing special about evolutionary theory here, involves talking about numbers. You talk about the existence of numbers that have a certain characteristic. That's a standard form of scientific claim. And if Platonism is right, you're now talking about things that do not exist in space and time, i.e. they do not exist in nature. They must be supernatural. Let's go ahead. Okay, I just talked about the second argument. Now I want to move to the third one, the idea of being that if you introduce God into science, into evolutionary biology, the science will collapse. It will go up in flames. It'll ruin science. You won't get it'll destroy science, basically. And I want to consider that argument. Let's go ahead. Oh, no, that's the next slide? Oh, no, sorry, I wanted to do the second argument. I haven't done that one yet. Okay, sorry. So now we're saying, here's the reason why you shouldn't put God into your science, because it'll make the propositions in your science untestable, because statements about a supernatural God are never testable. That's the argument for methodological naturalism that I want to talk about now. And it's wrong, because there are testable statements about supernatural entities. Here's one of them. A supernatural deity created life on Earth 10,000 years ago. We've got plenty of evidence that life on Earth is a lot older than 10,000 years. So we've just therefore that's a testable statement. So not all statements about supernatural entities are untestable. Next slide. Here's a bit of an irony. So the logical positivists, the Vienna Circle, the Berlin Circle, which flourished between World War I and World War II, and whose some of these people came to the United States and transformed philosophy of science. Thank you, Hans Reichenbach and Rudolf Carnap, for doing that. They thought that scientific statements aren't all testable. Some of them are, others are not. Carnap and Reichenbach both thought that scientific theories include conventions, which we adopt not because we have empirical evidence that they're true, but because they're convenient. Let's go ahead. Karl Popper, perhaps the most famous philosopher of science in the 20th century next to Thomas Kuhn, thought that all scientific statements are testable, by which he meant falsifiable, and that that's what marks the difference between science and non-science. This has had a huge influence, this idea that falsification solves the demarcation problem. The demarcation problem is the problem of saying how scientific statements differ from non-scientific statements. And I don't want to get into Popper's solution to the demarcation problem, but I just want to point out that the positivists disagreed with Popper's solution, because they thought that scientific theories contain untestable propositions, definitions, conventions, and also, of course, they contain empirical statements also. And I think in this regard, the positivists were clearly correct. There are definitional truths in evolutionary biology. There are definitional truths in Newtonian physics. That's how scientific theories are built. That's not all there is in the theory, but some of the propositions in these scientific theories are definitional truths. They're not empirically testable. Okay, let's go ahead. So what did Carnap have in mind by the conventions? This is maybe a little bit of a detour from the main topic. He thought that the assumption that physical objects exist and the assumption that numbers exist is not empirically testable, that scientists adopt these assumptions because they're convenient and then proceed. So a physicist will assume that physical objects exist and then will use that assumption to decide more specific things, like do electrons exist? Do photons exist? Do quarks exist? And mathematicians will assume that numbers exist and then will use that assumption to try to decide what kinds of numbers exist. For example, is there a largest prime number? So these are framework assumptions for science. They're not empirically testable. That was the view that Carnap had. Let's go ahead. Okay, so now I come to, I hope you see why I reject the first two arguments in favor of methodological naturalism. I'll consider the third, which is the idea that if you were to introduce God into science, it would stop science, it would destroy science. So let's go ahead with that one. I think what's true here, if introducing God into your science led you to think that the only explanation you will ever consider is God did it, well, yeah, that would destroy science. Let's have the next slide. But that doesn't show that mentioning God in any form is going to stop science. You just shouldn't get carried away. I mean, you've got to kind of constrain what God is allowed to be appealed, when you get to appeal to the existence of God and when you do not. So I think the science stopper argument confuses the first of these items on this present slide with the second. Let's go ahead. Okay, so those are the three arguments that are kind of out there in the literature defending methodological naturalism. I don't think that any of them are compelling. So let me try to do better now with the next slide. Here's, I think, a better and a more modest argument for methodological naturalism. It says, look, theistically neutral science has been a big success, and it's questionable whether a theistically committed science would do better, and it might do a lot worse depending upon how things played out in the world of science. And so the conclusion I draw from that is, next slide, if science isn't broken, don't try to fix it. Don't monkey around with science in a way that could possibly have terrible consequences. Okay, let's go ahead. Well, you might be wondering, if numbers are supernatural entities and God is not, why are scientists entitled to bring numbers into their theories by having mathematical theories, but not what? But on the other hand, they shouldn't bring God into their scientific theories? And I think the simple answer is that because you need mathematics to do science, and I don't think you need God to do science. And I take that to be, just by empirical inspection of the way science has developed. But I don't think that the fact that you need some numbers to do science is evidence for the existence of numbers. And the fact that God is not needed in science, I don't think that's much of an argument for the non-existence of God. Okay, let's go ahead to the next slide. So here's the main thing that I've been talking to you about today. First of all, there's the idea that evolutionary theory does not rule out the existence of a God who intervenes in nature. I talked about guided mutations in that context. I'll emphasize yet again that I'm not saying that God does intervene in nature. I'm certainly not saying that mutations are guided. But the theory, I think, as I understand it, doesn't rule out that God should do some things in nature that scientists will never detect in their laboratories. I try to argue that methodological naturalism is a good idea, but not for the three usual reasons that one hears about in defense of methodological naturalism. So let's go to the last slide. Thanks. I'm done.
Thank you very much, Professor Sober, for your talk. I think maybe we have some questions. I don't know if Duems has recorded some questions so far. It seems that Eimer Alonso has a question. Eimer, do you want to make a question?
Thank you, Santiago. Thank you so much, Elliot. It was an amazing talk. My question is about the first part. When you were talking about mutations are unguided, there is evidence suggesting that mutations also unguided could be induced.
I didn't understand the last word you used. Whether mutations, say that again, please.
Unguided?
Yes.
But there is scientific evidence it could be induced by environmental stress, for instance.
Sorry. Yeah. Now I understand. I didn't get inducive.
Ahí se puede automatizar más todavía. Me dicen si les parece sensato, si les parece que.
I understand the idea. So environmental stress does increase mutation frequencies, but it increases deleterious mutations to increase in frequency because it increases basically all mutations, good and bad, to go up. And if you'll remember the sort of inequalities that were in the 2x2 table I was showing you, that's not enough for guided, that's not guided mutation. So mutation frequencies do change, but the idea of guided mutation is saying something more than the fact that the frequencies of mutations change depending upon the environment.
Aimer, are you okay with that answer? Maybe I mean, if you want, you can also reply.
Well, just a short reply is that fact leave the open for teleological question. Well, again, so it's open the door for teleology in evolution if we talk about induced mutations.
Suppose mutations were guided in the sense that I defined it, then there's got to be some mechanism inside of organisms that decides when the environment changes what mutations would be good and which would be bad, and let's make the probability of the good ones go up. That mutational mechanism, it would be an amazing thing to have something inside of an organism's body that would help it out by giving it useful mutations. These would be transmitted to its offspring, be very adaptive. And it would be natural to say of that machinery that it has a function. And if that's all you mean by teleology, I'm okay with it. Look, we're okay in biology saying that the heart has a function. Its function is to pump blood. It's not like Darwinians should be happy to say that. If there were a machinery guiding mutation, that would have a function also. I don't find that an objectionable teleological thing. Sometimes people talk about teleology as something that's stranger and more objectionable than talking about function. If that's how you understand teleology, okay, then this is not teleological. But if what you mean by teleology is just that we're happy to talk about the function of organs and processes inside of organisms, then yeah, it would be teleological, but not in a way that's objectionable. Let me give you an example. I mean, when you first start learning about other organisms, when maybe you're a child, I remember being amazed to be told that there are organisms that when you cut off one of their limbs or even cut off their head, they'll grow a new one. I remember being shown experiments on planaria that can do that. I was like, that's incredible. Well, this is amazing when mammals like us look at these organisms and say, wow, they can do this amazing thing. But of course, that doesn't make evolutionary biologists say, oh, there's no way of explaining this. We just start looking at the mechanisms inside of planaria that allow them to do this amazing thing. It's part of, you could say, I want a naturalistic explanation of how planaria are able to regenerate lost limbs, lost heads. If biologists ever came up with evidence that mutations are guided, I think they would say, wow, that's really incredible. Let's figure out a naturalistic explanation of how they're able to do it. We look for the mechanism that causes useful mutations to increase in frequency when they become useful. So there's no threat to naturalism here. There's no weird kind of teleology that enters the story, I don't think either.
Thank you.
Thank you, Elliott. Now we can give the Duyan has the chance to make his question. Duyan, go ahead, please.
Okay. Hi, Professor Soba. Are you hearing me?
Yes, I can hear you.
Okay. Thank you very much again for accepting Santiago's invitation for this talk. It's a very good pleasure having you here meeting the reading group for philosophy of science. It was a wonderful talk, and so I have a lot of questions, but just let me formulate one question, which is not about what approach actually says, but about what it seems to suggest. And you claim that evolutionary theory is evidentially neutral regarding the proposition that there is such a person as God, regardless deism or theism. But it seems to me that your approach, yes.
No, would you like to? I mean, I could comment on that, but maybe why don't you just continue, and then I'll try to remember what I was just about to say to you. Go ahead, please. I'm sorry I interrupted you. Go ahead.
Okay, my precise question is the following one. It seems to me that your approach is involving not only that scientific theories, in particular evolutionary theory, should be neutral with respect to the proposition whether there is such a person as God, but also science, both theories and evidence should be neutral with respect to philosophical questions more generally, not just about the question about theism, but also metaphysical questions, for instance, whether physical objects exist or something like that. So what do you think about the scope of this
Okay.
evidentiality approach?
Good. I'm glad you asked me that question. So it matters a lot how you define God. So a creationist who says, look, my definition of God includes the idea that God created life on Earth 10,000 years ago. Well, if that's what you mean by God, evolutionary theory is incompatible with that version of theism, because we know that life is much older than 10,000 years old on Earth. So it really, a lot depends on that. So so I don't want to say in a kind of unconditional way that evolutionary theory never says anything of relevance to the question of whether God exists. I mean, you got to think about what you mean by God here. So here, let me make the same point in connection with a different definition of God. Deism says God created the universe, created the laws of nature, and the initial conditions of the universe, and then God never did anything in the world after that. The universe just played out according to its own laws, and from the initial conditions moved forward, and the history of the universe unfolded. Now that's a version of God's existing. Evolutionary theory, I think, is obviously compatible with that. Because evolutionary theory is about what happened relatively recently. It's not about the beginning of the universe. Maybe physicists who do cosmology would have something to say for or against that picture of God. But biology, I don't think is really talking about what happened at the beginning of time. You see what I mean? So that's you see here again, it depends how you define God, what answer you're going to get to the question, does evolutionary theory have anything to say about it? Go ahead, Duems.
So is methodological naturalism restricted to consideration of evidential support between evolutionary theory and theism, or we can extend methodological naturalism for considering other metaphysical questions? For instance, humans have free will, like that.
Okay, let me, before I get to let me talk about the evidence part of what you were saying. So when I formulated methodological naturalism, it wasn't a statement about evidence. It was a statement about what goes into a scientific theory. That is, what propositions should be in your theory or should not be in your theory. And that's separate from the question of what evidence there might be for your theory. Well, let me give you an evidence. I mean, let me get closer to the evidence thing. And I know I'm not now going to talk about the questions you want me to, but I'll get to that in a minute. Here's a familiar empirical argument against the existence of God that I'm sure you're all familiar with. It's the problem of evil. You look around the world and you see so much suffering. You say, there's no way that a benevolent, omnipotent, omniscient deity could exist. An all-powerful, all-knowing, and entirely good being would never have allowed the world to look the way it does. Therefore, the amount of suffering we see in the world is evidence against the existence of God. This is, by the way, this is an argument that Darwin took very seriously. That's why he stopped being a theist. The problem of evil was what moved him. The existence of suffering is, to me, a scientific matter. Scientists can tell you what kinds of suffering there are. So that's, to me, a scientific argument against the existence of God. I've got nothing against that. That's fine. But now we're talking about scientific evidence against the existence of God, which is a different topic from whether a theory in science should have God's existing inside of it. Okay, so I'm just trying to separate some of the different ways of thinking about the relationship of theism to science. Well, let me take up some of the questions you asked before. You mentioned a minute ago, Dubian. You mentioned free will. I don't see. I mean, I don't know that evolution has much to say about that, but psychology might have something to say about that. And of course, everything will depend upon what you mean by free will. So I'm not advocating the idea that scientific findings are never relevant to philosophy. That's way too ambitious a claim. I don't believe that. And so, for example, just as an example, you mentioned this, I think. Philosophers used to believe that determinism is true. That the state of the universe at one time guarantees that there's only one possible future after that. There's only one way the world can unfold given its present state or given the initial conditions of the universe at the very first moment. And this was often defended on a priori grounds. And then quantum mechanics came along 100 years ago. And I think since quantum mechanics is such a successful theory, we now have some reason to think, well, maybe determinism is false. So that's a historical example of how an idea that was a philosophical idea turns out to be undermined by a scientific finding. Fine, that's good. I mean, I'm happy when that happens.
Thank you very much, Professor Sober. Now we have a question by David Velasquez. David.
Thank you, Professor Elliott, for your talk and to join us. So my question basically is if you consider that, or that it can be considered any kind of progress in evolution.
If progress means better and worse, not just in terms of adaptation, but morally better. I don't know what you mean by is progress meaning better adaptation?
Well, it can be that can be one of the meanings, but as well, I was thinking about, by instance, it can be like more diversity. So that can be another measure of progress, right? So I would like to know if you have a position about the progress, about the relation between progress and evolution.
Natural selection can sometimes improve how adapted organisms are. It sometimes can make populations less adapted than they were before. That happens when you have frequency-dependent selection sometimes. Also, if the environment is changing faster than the organisms are evolving, they'll get worse and worse in terms of their fitness, though natural selection is driving their evolution. So selection does not always improve fitness, not by a long shot. As far as complexity goes, life started very simple as far as we now know. And so initially there was an increase in complexity. But as Darwin points out, sometimes evolution takes us in the direction of simplification, not in the direction of greater complexity. That's what the evolution of parasites is all about. Parasites are simpler than their free-living ancestors, typically. So sometimes complexity increases, sometimes it doesn't. Diversity at the level of ecosystems, that improves, except when there are mass extinctions, and then it declines. So, I guess in all these cases, I'm saying the word sometimes. Sometimes yes and sometimes no. I guess that's as much as I feel like I can say about it. And all these different ways of thinking about it are different from the question of whether there's moral progress. I mean, Darwin, he thought, he said that the existence of the higher animals is one of the most marvelous, valuable things that's ever happened in the universe. Thank you, evolution, for making that happen. So when he was talking like that, he was thinking of these good outcomes, not just improved fitness or diversity, but sort of admirable, beautiful, good things in some sort of ethical sense. The universe is a better place because the higher animals exist, he thought. Yeah, I guess I kind of agree with that. I don't think that that's a scientific statement I just made, however, because good in that sense is about morality and value. And to me, now we're talking philosophy. That's not a finding of evolutionary biology anymore. It's something that we've added to it, as Darwin was happy to do.
Okay, thank you very much.
Thank you. Now, Cristina, you have the opportunity to ask.
I think Camilo goes before me.
Okay, Camilo, please.
Thank you, Chris. Thanks, Dr. Sober. I think it is very stimulating for us having you here and having this discussion. I will ask a question with two phases, I would say. The main question is, of course, we can recognize, I think it is very compelling, your argument about the possibility of having hidden variables in the origin of mutations. But does the evolutionary theory not require and the methodological naturalism in evolutionary theory does not require those hidden variables to be natural in the terms that you gave as the definition of natural, so being in space and time? That can be thought also in the sense of the current evolutionary theory, updated with all the mutation theory and all the causes that we already know for the mutations to occur. That is the main phase. And the other one is that.
Well, let me answer this question before you go ahead to these. It's two questions. Is that right?
Yes.
Okay, so let me start with this one. The reason I stopped you is because I tend to forget the first question when I hear the second one. So why don't want to let that happen? Okay, I think I still remember your question. Yes, methodological naturalism tells you when you look for hidden variables, make sure that they're occurring inside of space and time. Don't bring God into it. Absolutely, that's what it says. And I think it's good advice. However, I also think that theory itself, let's call methodological naturalism a philosophical attitude towards science. And of course, therefore, a philosophical attitude towards evolutionary biology. And that's different from the theories we write. Just look at the theory of evolution, in particular the theories we have about the causes of mutation. The theory is compatible with there being hidden variables. And therefore, the theory, as stated, is also compatible with there being supernatural hidden variables. Now, that's just what the theory says. And you might think then, well, as a scientist, how should I go about thinking about this problem about are there hidden variables? And then methodological naturalism gives you the advice of look for hidden variables that you can detect in nature. And one of the things that seems to be a drawback about thinking of God as the cause of mutation is like, how are you supposed to get evidence for that? So yeah, I completely agree with what you said, that methodological naturalism tells you when you're thinking about hidden variables, look for things inside of nature that are making a difference in mutation frequencies. That's how you do science, for sure.
Okay, and my second question would be related to the argument about the use of numbers and the role of numbers as for the existence of supernatural entities in evolutionary and other scientific theories, of course. So don't you think that there is a difference in between a role of numbers and a role of other supernatural entities like deities, in the sense that numbers are not considered causes in our theories, but when God is brought into the picture, is always, I would say, always brought as a cause of the phenomenon. Thank you so much.
Yeah, that's a good point. Here's a way in which numerical things are sometimes brought in as causes. I mean, it's not exactly what you were asking me, but let me describe it. So you may remember discussion of why periodic cicada have prime numbers as their periodicities. I guess a lot of species do. I don't know how common this is, but anyhow, Stephen Jay Gould used to talk about this, and philosophers of biology have taken up this example. And it seems like the fact that an interval is a prime number causes cicadas to evolve the periodicity they do. That's at least the theory, because if you have the number 7 as your periodicity, the only way a predator can get in sync with you is by doing a 7 periodicity itself, or being around every year. Whereas if I have 8 as the periodicity, you can get in sync with me by doing every year, every 2 years, every 4 years, or every 8 years. So you're evading predators more effectively if you have a prime number periodicity. So it looks like the numerical property that a period has, namely as a prime number, is causally relevant to how natural selection works. Now, but your point was right. It's not like, we're not thinking that the number is doing any causal work, but it's a numerical or a mathematical property of a physical thing, namely the periodicity of the cicada, that is causally relevant there. But yeah, but you're right, that's a difference in just the examples that I was describing, where numbers are not, they're absolutely indispensable in science, but scientists don't regard them as the causes of things. They're somehow part of the language of representing the causes, something like that. Yeah.
Thank you very much.
Now it's Christina's turn.
Hello. Well,
Hello.
thank you so much for your talk. It was really interesting. I definitely agree with you that science should remain theistically neutral. I think it has been, very successful doing that. But what I don't understand completely from what you presented is why you think that a scientific theory like evolutionary theory cannot rule out supernatural entities. So if I understood you correctly, when you're making your arguments, you're proposing things like it's relatively limits, for example, to say that science only studies natural things. Yes?
Creo que se te cortó un poquito. Tal vez vuelves a, desde cuando tú dices, when you say.
Okay, so I'm gonna turn off the camera to see if that helps. So I just want to understand better why you are claiming things like it's trivial to put limits on science. I think most scientists will agree that it's very important to say that science only studies natural things. But the one I'm really curious about, and I would like you to expand on, is you say supernatural claims are testable. And you have an example. You say, okay, if you say God created life 10,000 years ago, you can test that. I disagree with you, because I think what you can test is the second part of the statement. You can test that life was created more than 10,000 years ago, but you cannot test that it was God that created that life. I mean, let's say you have a scientific theory, or we have a lot of evidence that says life appeared on Earth 4 billion years ago, and then you have, in contrast, another hypothesis that says, no, it was not something, materialistic, it was God, and it was 4 billion years ago. So now, the part that you need to actually test is whether it was God or some other natural force. And I will say you cannot gather any evidence to claim that it was not God. So I just like you to expand on why do you think supernatural claims are testable?
I don't think all of them are, and maybe the example you gave of God exists is not testable. But the example I used was different. It's the proposition about God that said that God created life on Earth 10,000 years ago. And as you say, that's testable because part of it is testable. So I agree with that. There's a general thing that I'd like to add to that, which I didn't mention in the talk. So there's a sort of standard idea in philosophy of science called Duems Thesis, named for Pierre Duhem, the early 20th century philosopher of physics and historian of science. So Duhem said that he was talking about physical theories. Physical theories, he says, are not testable by themselves. That is, by themselves, they don't tell you what you should observe, but they become testable when you add what he called auxiliary assumptions to them. So the and I think philosophers of science have generally come to agree with Duhem about this, and to generalize it, it's not just the fact about physical theories, it's a claim about lots and lots of theories in all sorts of science. It's a very general, correct claim. So, for example, relativity theory is compatible with the universe being empty of matter. It doesn't tell you much of anything until you start to add additional assumptions about what exists, and then you get all sorts of predictions out of it. So the basic pattern is, in that example, the theory by itself does not predict anything, but the theory can join with further assumptions that larger conjunction of statements that can have predictive consequences. So that seems to be a correct claim about lots of different scientific statements. It's also a statement about this example you gave. God exists by itself. I don't know what that predicts, especially if you haven't defined what God is. I don't even know what's being said there. But in that respect, it's like some scientific theories, which by themselves don't predict any observations. If you add assumptions to them, they become testable. And that's, in effect, what happened in the example of mine that you were talking about. Maybe God exists doesn't predict anything, but God created life on Earth 10,000 years ago, predicts a lot. That's how we know it's false.
Right. Thank you for the additional comments.
So now we have a question by Oscar Sanchez, but he says that he doesn't have a microphone, so I think that I'm going to read it for him. He says, if you characterize natural entities and processes as existing in space and time, and supernatural interventions would, no, sorry. If you characterize natural entities and processes as existing in space and time, supernatural interventions would violate causal closure principle. If God supplements evolutionary process, God would violate this principle. Those are our questions.
I agree. If causal closure means that the only things that cause physical events or other physical events, where physical events have to occur in nature, then divine intervention violates that principle.
Okay.
Fortunately, I was not defending the claim that God intervenes in nature, however.
Okay, now we have a question by Aldo Martinez. Aldo, would you like to ask your question?
Thank you very much. Thanks, Santiago. Thank you very much, Dr. Elliott. I just want to make a comment. Numbers are not real entities. They are abstractions. They are very useful for quantification, but in opposite to God, they are not first causes. Unless you're a Pythagorean, numbers could be your arche. But in modern science, it's much more Aristotelian, not Platonic. I also want to say prime numbers are not infinite. And then for us, what could be something supernatural, something beyond an outside space and time, but like what could be love or anything else? Sorry, could you be more specific, please? Thank you very much, both of you.
Okay, let me see. I think the statement that there exists a prime number between 6 and 8 is a truth. The statement that there exists a prime number between 6 and 8 is true, and it's no less true than the statement that there exists a city between one or more cities between your city and my city. I mean, the first one is not about physical objects and the second one is, but they're both true and they're both existence statements. So I agree that the concept of a number involves some abstraction. I mean, when we think of the number 7, there are lots of things that can be 7 in number, and they can be physically very different from each other. So in formulating that concept, we're abstracting away from all of the differences that there are between 7 apples and 7 symphonies and 7 novels and 7 species. So there's the numerical concepts involve a lot of abstraction. The concept of the city involves abstraction also. Think of all the different cities there are on our planet. They're very different from each other in many, many, many ways. And yet we're able, the human mind allows us to formulate a concept that applies to all of them, despite the fact that they're so physically different from each other. So abstraction is part of that's so important in the way we form our concepts. It's not unique to mathematical concepts. Basically, all the concepts we have involve this process of abstracting away from differences between things to identify similarities.
Thank you.
I don't know if that addresses everything you were mentioning, but.
Okay, now we have the question by Erika. Erika, please go ahead.
Yeah. Thank you, Santiago. Thank you very much, Professor Elliott. I have a question related to Camillo's, and it has to do with hidden variables and the model mutation. So, as far as I understand, one of the main purposes of methodological naturalism is to control variables. because when we control our variables, we are able to predict some results, some processes, and controlled variables have these. They are testable and they can allow us to predict our results. So they have an explanatory role. What is the reason why we would have control variables in our explanations? So it seems to me that according to your approach, the supernatural entities or supernatural stuff allow us to introduce hidden variables in our explanations. But one of the main characteristics of hidden variables is that they are not testable. So they don't have this predictive power. So I was wondering to what extent the hidden variables have an explanatory role. Why do we want, or what we should allow those hidden variables in our explanations? We want to explanatory role. So thank you so much.
Yes, I agree with your thoughts there. When we're doing science and we introduce a new variable because we think there's something missing in the existing theories and we need to supplement those theories or maybe replace them, but just think of the case of supplementing the theories by saying, yes, X, Y, and Z are causes of the phenomenon, but W is also a cause. Yes, the practice is you want the introduction of W to lead to testable predictions. And if it doesn't, a scientist will say, what are you doing? I mean, you're wasting my time. Yeah, absolutely. Okay. So I like methodological naturalism. But see, liking that as a sort of regulative principle is different from saying, let's look at the theories we have and see whether the theories themselves, rule out this, that, or the other thing. So one of the distinctions I'm using is what a theory says, and then separable from that is the methodological attitudes that we think are appropriate in building theories, in evaluating theories. So I like methodological naturalism.
Okay, thank you so much.
Now I have a question by Eric. Eric, go ahead, please.
Yeah, thank you. I have a question regarding, well, I would like to know, Professor Sober, if there's if in your mind, or if you could imagine a plausible version of a theory, or let's say of that position that includes these theistic considerations in doing science. I ask this because, well, in your presentation, a lot of the examples of this kind of propositions that are involved in a scientific explanations, let's say, for example, if whether there is God exists or not, or these propositions concerning the exact age of life on Earth, or of Earth itself. These considerations, these propositions certainly seem explanatory idle, let's say, and they come from well, the teachings of certain organized religions. These are propositions, and one can find on Christian scripture, for example. But I don't know. Can you think, or are you aware of a position that includes this kind of theistic considerations, but in a more interesting or in an interesting way? I mean, and what I mean by that is a position in which these theistic considerations do a real explanatory work. And I don't know if that.
No, I don't think so. I think that the attempt by creationists and intelligent design theorists to bring God into science has been a colossal failure. They haven't advanced science at all. And these same things come up when you think about arguments for the existence of God that appeal to physics, like the fine-tuning argument. I don't think that's advanced science at all. So, yeah. I mean, just to put this in a little bit more context, I mean, the people who present these arguments believe that they are solving a problem that science, at least as it's presently constituted, cannot solve. And if they were right, they would be advancing science. I mean, and I think many of them believe that. I don't think that's what they think. I mean, I think they're incorrect about that, but they agree that a theory is worth stating if it contributes some positive understanding that you didn't have before. But in fact, I don't think that's happened. So that's why I think creationism is a waste of time. Intelligent design theory is too. Just back to biology a little bit.
Yeah. Related to that, I don't know. Would you think that, for example, such a thing like a non-denominational concept of God, for example, in your opinion, that is there such a thing, or such a thing could be like, I don't know, for example, Spinoza's God that is identical with nature or something like that?
Well, Spinoza's God obviously exists because God and nature are the same thing, and nature exists.
Yeah.
The totality of objects in space-time obviously exists. It's kind of ironic that Spinoza was accused of being an atheist, where what he meant by God obviously exists. But of course, the word atheist was used with a different meaning back then. It basically meant denying Christianity or some form in some way. So, yeah, Spinoza's God is not a person; it's just nature. But to me, that's not how I use the word God. I mean, I think God has got to be a being with a mind who does something, and that's not what Spinoza was talking about.
All right. Well, thank you very much.
Okay, thank you very much, Eric. And now we are coming to the end, and we have the last question by Wendy. Wendy, please.
And hello, thank you so much for the talk. I was just wondering about the supernatural character of hidden variables, because before you said that hidden variables cannot be tested, but I was wondering if you can sort of test them in a Bayesian framework more than on a likelihood framework. And I'm thinking particularly about an example about populations. I will just turn off my video, because populations can be considered as a hidden variable in a sort of Bayesian framework, and you are just observing how different, like if you are observing clusters and you have like a hidden variable that can be that populations were separated before, for instance, in 3 different mountains or something like that. So yeah, that's my question, if a Bayesian framework wouldn't be more appropriate to sort of characterize hidden variables.
Help me understand the example you're describing. So we have something in population biology, and the question is whether we're going to introduce a hidden variable to help us explain data. And can you give me just a little bit more detail about the kind of problem you're thinking about?
I'm thinking about, for instance, you see a group of beetles here in Colombia, and you see that they form clusters, and then you can have a hidden variable that they were before distributed in 3 mountains, but then there was like a climatic fluctuation and they become in contact, but they were separated before in 3 different mountains, for instance. But the number, I mean, the hidden variable there is the number of populations that generated the distribution of frequencies that you observed, like now.
Are these things that you're calling hidden variables, are they causes or effects in the problem you're thinking about, or both?
I mean, it's hard to, because the differentiation is because gene flow is interrupted, but I think that the hidden variable that is causal is that specifically it was interrupted between a population, but now there is like these specific barriers that makes this group to be divided in 3. You know what I mean? So
I do, yeah. So would the following be sort of close to what you're thinking about? So you have these 3 populations, and they're different from each other in several ways, and they're similar sometimes in several ways also. And you'd like a full explanation of this pattern of similarity and difference. And you start out and you say, well, here's one thing that I think is relevant. And then you recognize, well, that explains some of the data, but there are parts of the data that haven't been explained by the thing you mentioned. So we then introduce a new concept that will be introduced to explain another part of the data, and so on. You keep introducing new variables to explain more and more of the observations of similarity and difference. So yeah, you're making your theory at each step more complicated, but the reason that's okay is that at each step you're explaining more and more. So that sounds fine. Yeah, sounds good to me. Have I grasped your question?
Yeah, I was just curious why you usually, I mean, have like frame things in a likelihood framework more than on a Bayesian framework.
Okay, I didn't mention that. Okay, so let me try to answer that question by not talking about hidden variables. We're just talking about likelihoodism and Bayesianism. So Bayesians typically, especially if they're philosophers, but often if they're scientists, want to assign prior probabilities to the theories or the hypotheses they're testing. And likelihoodists think that that's often not a defensible thing to do. You can't justify your assignment of prior probabilities. But both likelihoodists and Bayesians do want to talk about the likelihoods, namely the probability of observations given hypotheses. So that's common ground between likelihoodists and Bayesians. Where they differ has to do with whether they want to talk about the probabilities of hypotheses, not just the probability of data given hypothesis. But I think they would both agree that if you're going to bring a new causal variable into your theory, the place to begin is to seeing how does that new idea change the probability of your observations. You wanted to do that, or else people are going to say, well, why are you bringing that in? It doesn't seem to change anything important in my theory. You're just bringing in an extra kind of irrelevant thing. So the idea of making contact with the data is important. And the reason, and the way that gets represented formally is in terms of likelihoods, typically.
Okay. Thank you very much, Professor Elliott. We are very glad that you have shared with us your research. We have discussed like many of our topic of interest, like Darwin, evolutionary theory, of course, metaphysics and God existence. And so we are very grateful that you share with us your research. And we hope to keep in touch and be able to meet again to discuss topics about philosophy of biology and philosophy of science. Thank you very much.
Okay, thank you. I enjoyed our conversation.
Thank you. So,
Okay.
stay well, and thank you very much. Bye-bye.
Okay. You all do the same. Bye-bye.
Antes de que todos se vayan, un último mensaje, tal vez en español. Esta charla y esta conferencia son una preparación, hacen parte de una preparación para un curso de filosofía de la biología que estamos preparando entre varios de los profesores aquí reunidos, Camilo, Duyan, Cristina, y bueno, esperamos que todos ustedes también estén implicados de alguna o de otra manera. Y bueno, les agradecemos a todos los asistentes por venir y conectarse. Y bueno, les deseamos un feliz día.
Santi, muchas gracias. Muchachos, muchas gracias.